can now compute the standard error. That will be standard deviation divided by the sample size. Over here, the sample size we are taking is 60 square is 16. So therefore, sigma of x bar would have a value 0.30 divided by square root of 16 is 4, would give us 0.075 as a standard error value. Over here you can take notice of one thing, that we were using the formula z equal x minus mu divided by sigma in case of one selection. Now we are using the formula, or we have to use the formula in later parts of the question as this one. And to get transform any given value of x, what we were doing previously, we were subtracting from x value the mu value and then dividing it by standard deviation. Now what we do, over there standard deviation value was 0.3. Now what we do, each value of x bar again is adjusted with the in the form of difference with respect to the mu value, and then we need to now divide it by the standard error. Standard error value is 0.075. Now I am going to write down the working desired in the new parts of the question. Part D up to part D we have, in fact part D we have discussed, part E we have discussed, part F we have discussed. Now we will move to part G. And for part G, this is the piece of information. Again, I am copying. The mean value is 6.7 centimeter. Sigma is equal to 0.3 and the sample size is of 16. Now, let's suppose in part G we are asked for the probability of x bar to be less than 6.55 as we were given. In case of x, the same value. The part A description was probability of x to be less than 6.55. Now we are asked for probability of x bar to be less than 6.55 in part G. Then in part H, what we will do, same value we will carry on with. Over there it was 7.3 for x. Now it is 7.3 for x bar. Part I over there was given as 6.3 for x bar to 7, and J part will have the same description. Between what two values symmetrically distributed around the mean, will 60% of the sample mean values fall. So it can also be read as what fraction of the sample mean will have the value below 6.55, what fraction of the sample means will have the mean diameter greater than or exceeding 7.3, what fraction of the sample mean values will have the diameter value falling between 6.3 and 7. So over here I'm using the word fraction, and fraction is a synonym of probability. Whether we use the word probability or fraction or proportion, it has the same meaning. So we now get the new values of x bar, in fact old values of x now transformed as new value of x bars. So we will make use of this formula we know. And then what we do, 6.55 minus 6.7 divided by zero point 0.3 and divided by square root of n that we have worked out already as 0.075. And this time, in to convert each x bar value to corresponding z value, we need to divide the difference of x bar and mu by 0.075. So transforming this value into the new value of x bar, this would give us z value below minus 2. Because you can work this out and you will get the idea that what will be the answer. So 6.55 and then divide by 0.075. 6.55 would give you most probably your answer as minus 2 when divided by 0.075. So when we check probability from the table, z table gives us across minus 2 the probability of z as 0.0228. We substitute this, find out this answer, and now the probability of getting the sample mean value to be less than 6.55 is 0.0228. Similarly, when we substitute this value 7.3 in the formula, z equals 7.3 minus 6.7 divided by 0.075. So what we get as our answer, z value, let's check with that perfect calculator. I am also doing it on my part. 7.3 take away 6.7 divided by 0.075 gives you 8 as the z value. Very larger value of z we are ending up here. And now let's consider, first of all, we need to know the way to answer this. This should be rewritten as 1 minus probability of z below 8. Now referring the z table for such a large value of z, we need to read the statements provided in the end of each table. In the negative z table, in the end of the negative z table, in fact, we are given a statement that for any value of z less than or equal to minus 3.9, the area is 0. Similarly, we are given any value of for any value of z to be greater than 3.9, the areas are 1. So it does indicate that the entire curve is accumulated till 3.9 value. 3.9 value of z is located on the extreme half part of the curve, positive part, in fact. So if probability of z across 3.9 is 1, across 4 it will also be 1, across 5 it will also be 1, across 8 it will also be 1. So what we get as our answer, 1 take away 1 is 0. No chance the sample mean diameter will have the value exceeding 7.3. There is no chance for that. Now similarly, if we get these two values converted, that's 6.3 take away 6.7 divided by no point no 75 would give us minus 4 as your answer. Similarly, 7 take away 6.7 divided by 0.075 would give you 4 as your answer. So minus 4 would be the corresponding lower bound for z, and plus 4 would be the corresponding upper bound for z. So over here we can rewrite down in this way, and that would give us the probability across 4 we have just dealt with in the previous part is 1, and the probability across minus 4, because in the table it is given as a piece of information that if the probability across minus 3.9 is 0, then across minus 4 will also be 0. So 1 take away 0 is 1. So there is a 100% chance for the sample mean diameter to fall between 6.3 and 7 centimeters. Now dealing with the last part, as step number 1, we will do the same thing what we have done in part D already. We will draw the curve. We will select the middle 60% area under the curve. Consequently, we'll be left with remaining 40% area that should be divided equally to the two tail end regions. And when we have referred the table for this value, again I will show you the value corresponding to 0.2 probability, the value of z. So 0.2 probability is here. You can see 0.2005 is in the 0, 1, 2, 3, 4th column. So minus 0.84 is again the value, same value what we have got over there in case of x. So up to this point, your working will remain same. If the lower bound comes up with the value minus 0.84, the upper bound will have the same positive value. Now converting to corresponding values of C and D that are defined as the lower and upper bound for X bar for middle 60% of the sample mean values. The X bar has a lower bound C, mean value is 6.7 divided by no point no 0.075. Now again we will divide it by the standard error instead of standard deviation. For upper bound, our working should be 0.84 with plus sign equals D take away 6.7 divided by 0.075. Now again we will do the same thing. Minus 0.84 will be multiplied by 0.075, and then we add 6.7 to it, and this is how we get the answer for the value of C. Similarly, plus 0.84 multiplied by 0.075 and plus 6.7 equals D. So D will be equal to, C will be equal to 6.763, and D will have the value, sorry, 6.637 for D. For C, 6.637 is the value for C, and 6.763 is the value for D. This is how we get the answers for he can give a value.